Okay, we've been talking about dividing polynomials, and in the first one we saw long division, which is not very much fun, but it's really necessary to know that method because we're going to learn another approach called synthetic division, which is much easier, but it's limited in the types of problems that it can handle. Now there's some workarounds around that, but I'm not going to show those in this video. Um, so basically you need both tools is what I'm trying to say. Now I'm going to show you what synthetic division is doing, and you're going to wonder why it works, and I'll talk about that as soon as I'm finished. But what we're going to do is we're going to divide this. Let me see how they set this up. Okay, I don't like that. So we're going to divide by x minus 3. Well, we're going to actually divide it by the root. So like if we had done the zero product property, the root is 3. Like so if this equals 0, x is 3. So I'm going to take it as the 3. So if I had had x plus 5, do you see I'd be dividing by negative 5? Do you see? So the actual root would be negative 5. Okay, so I'm going to put that 3 there. I'm going to make this long L, and I'm going to put all the coefficients that I've got. Now synthetic is much easier than long division. All you do is this: bring down the first term, multiply them together. Now 3 times 5 is 15. Now add. Add that. You created 15, now let's add it up. We get 12. 3 times 12 is 36. Add them up. You get a remainder of 0. It's that simple. So again, here are my coefficients. Bring the first one down. Multiply. 3 times 5 is 15. Add 12. 3 times 12 is 36. Add 0. And you say, well, what does that tell me? Now we had 5x squared. So this is going to be 1 degree lower. This is going to be 5x, because it was x squared. We've sliced out 1. 5x plus 12 with no remainder. Do you see how easy that was? So much nicer. So remember, you're taking the root, not negative 3. You're taking the root, which would have been 3. Now, why does this work? Okay, if you looked at a long division problem side by side with this, you're actually doing exactly the same thing. It's difficult to wrap your head around, but for one thing, when you switch the sign here by making it 3 instead of negative 3, you've accounted for the minus sign. And you are actually following the exact same thing as long division. It is not intuitive that you're doing that, and no matter how many times I look at it, I don't see it. But if you watch it done side by side, you're actually doing exactly the same thing. Now, and you can find, I'm not going to do that, but I promise you that's the case. So you can check that out, find somebody else's video where they're doing it side by side. It's doing the same process. Now, it's doing the same process as long as this. You can only do the synthetic if you have this. You cannot do 2x minus 3. Your leading term on that x has to be a 1. Now there's a workaround that some people can do, but we're not going to do that in this course. So if you had synthetic, you can only do it if this is 1x minus whatever your root is there. Okay? All right. So yeah, this is useful to see. So when we divide this is where we're going to go with this in the future. We divide this, here's what it means. It means that these two multiplied together would get us back to what we had. They're factors. It means they're factors because there was no remainder. All right, let's try one here again. So be careful here. Do you see that negative 2? Let me see if I can use theirs. Yeah, negative 2 is what we need. Okay, we need the root, which would be x plus 2 equals 0. It'd be negative 2. I've got all my coefficients. First one down, multiply, add, multiply, add, multiply, add, and there is no remainder. Now, if you're not sure, remember, these numbers are 1 degree lower, so I have 4x squared plus 2x minus 10. So much easier, isn't it? Okay, now they've got an example finally. This is what I was talking about before. We need to account for the fact that we're missing. We need that placeholder here. Do you see there's nobody in the x places? So I'm going to put a 0 there. All right, so to make sure that I have 4, 3, 2, 1 all the way down, I've got that placeholder. All right, now our root is actually 1, so I'm going to divide by 1. Got all my coefficients, including the 0, and let's begin. We bring down -9, multiply, add, multiply, add, multiply, add. Now we go all the way through here, and this time we have a remainder. So we're going to kick this. What does all this mean? It means 1 degree less. -9x to the third plus 1x to the second plus 8x plus 8. And we have a remainder of 2 over that x minus 1 that we divided by. Okay, yeah, I think this is the last one. So I really recommend you pause the video and try it. Just notice here that there's nothing in the x squared place, so you have to put a placeholder. Okay, I'm dividing by the root, which is -7. Okay, so I've got 3, 18, 0, -3, and 40. All right, let's begin. We bring down the first one. -7 times 3 is -21. Add them up. Now we multiply again, we get 21. The placeholder, that's just going to be a 21. Okay, now they're getting big numbers and I've been doing this all day, so I'm going to get some help here. So that gets me -147. Add them up, get -150. Multiply again, I get 1,029. Add them up, 1,069. Okay, now this is not the answer. We need to say, well, what's the polynomial? So it's 3 with a x to the third minus 3 with an x squared. Now we had a remainder of 1,069 over that x plus 7 that we divided by. All right, I believe that's all we've got on this. So just don't forget about the placeholders. That's essential. You've got to make sure it's going to mess it up. And again, synthetic is limited. You can't do it if there is a coefficient in front of the x other than a 1. Again, there's a workaround, but we're not going to do that, okay?